Unit 8 is trig and non-right triangles. Another word that you might hear instead of non-right is called oblique. So if oblique triangles is something you're dealing with, that means you're going to use these formulas we're going to learn. 8.1 is using trig to find area of triangles and parallelograms. And so before I go over the formula, I want to show you this triangle. It's called TUV. Gives you U is 24 inches. And when you see a lowercase letter, that's a side length. And that side will be across from its angle capital U. So see across from here is side U. V is 29, so across from angle V, they've got labeled 29 inches. And then the measure of angle T is 130 degrees. Find the area of triangle TUV. So if you remember the formula for the area of a triangle, it's 1/2 times base times height. But I cannot call this 29 a base and this 24 a height. The height has to make a right angle. So if I were to drop down, it's called an altitude of a triangle. If I drop that down, this would make a 90. And so I've split this into two right triangles. So if I wanted to find the area, I would really be doing 1/2 times the base, which I would call 29. But I don't know what the height is, so I'll just call it H. Because I have right triangle here, I could go ahead and use SOHCAHTOA. So from this 130 degrees, I'm trying to find the opposite side, and I have the hypotenuse, because this is my 90. And so opposite hypotenuse, that would be sine of my angle, 130 degrees, is opposite is H over hypotenuse is 24. So to solve for H, I'm going to multiply by 24 times 24. So I'm going to replace H, and I get 1/2 times 29 times 24 times sine of 130. But I wouldn't want to have to do this formula every time. So what they've done for you is created this quicker formula that says that area will equal 1/2, which we saw here, A times B, and little a and little b are your side lengths here and here. So see how we had 29 times 24 times sine of your angle C, and that was sine of 130. So instead of having to do this, we can just use the formula. And so let's figure out what that is. So A equals 1/2 times, I would just look at the sides that are containing that angle. So what I mean is that angle has to be between these two sides. I couldn't use an angle up here if I knew these two sides. I have to have this angle. So times A is 24 times 29 times sine of 130. You should still be in degree mode. And we're going to take 1/2 or 0.5 times 24 times 29 times sine of 130. And it says round to the nearest square inch. And so this 0.5 would make this 266 round up to 267. So area is 267 squared inches. Okay, so again, I just proved why this formula does work, but again, this angle here is the angle that is included between sides, I'm going to say A and B. Okay. All right, so I don't know why that says number 3. Oops. Number 2 is now an area of a parallelogram. And so if a parallelogram has two sets of parallel sides, that's not very good, but these should be parallel and these should be parallel. A parallelogram is really just two triangles put together, and so instead of having half, now we're going to say we're doubling a half, which gets a whole. So now we just don't have the half in here. It's just A times B times sine of C. So again, these are the two side lengths. This is an angle of angle C that is between sides A and B. Two sides of parallelogram are 91 feet and 49 feet. So let me draw that real quick. So this is 91. This is 49. The measure of the angle between these sides is 86 degrees. Find the area of the parallelogram to the nearest square foot. And so we know that this is also 91 and this is 49. We could label here or here. Since this says 86 degrees, which is smaller than 90 in my picture, it makes more sense to have it here. Okay, and so then we'll do area equals side A, I'm going to call 49, times side B is 91, times sine of the included angle, I'll call C sine of 86. And then you just plug and chug. It said to the nearest square foot. That 1 does not make the 8 round up, so it's 4,448 square feet. And that's it.